Howdy. Mapping and magnetic superstorm. I have been watching just before the paper, and I figured out that maybe that's an easier way to present this. But anyway, here we have a map of the USA. We have red and blue. And here we have resistivity. Ohms per meter or something. Probably. I am not a scientist. So anyway, this is a resistivity map. So I assume where we have red, we have very low resistivity. Hence, we have conductivity, which is in a way the opposite of resistivity. Which means if this would be a conductivity map, the colors would be opposite. And this made me think because researchers have mapped the best and worst places in the USA to be during a severe geomagnetic storm. For residents of some big cities, the news is not good. Almost no news are good for residents of big cities. Because there are people, many of them. But anyway, resistive structures in the crust and mantle of the Earth make cities along the east coast of the USA especially vulnerable to geomagnetic storms, says Jeffrey Love of the US Geological Survey, USGS, who led the study. Hazards are greatest for power systems serving Boston, New York, Philadelphia, Baltimore, and Washington, D.C., a megalopolis of over 50 million people. Megalopolis. There are a few towns in the world which have more than 20 million people. One town. But anyway, these conclusions are based on a new study of the biggest geomagnetic storm of the space age, the Great Quebec Blackout of March 13th in 1989. Millions of Quebecois spent a long winter night without lights or heat after a pair of CMEs hammered Earth's magnetic field. The Hydro-Quebec power grid was down for more than 9 hours. What would happen if the same geomagnetic storm struck again? That's what Love's team wanted to find out. They combined old measurements of magnetic activity during the 1989 storm with new measurements of Earth's crust to pinpoint the hazard zones. At this point, it may be useful to review what happens during a geomagnetic storm when a CME hits Earth's magnetic field. Earth's magnetic field, our magnetic field, vibrates. If you had a sensitive enough compass, you could see the needle quivering. Next, because of Faraday's law, electrical currents begin to flow through conductors. Power lines, pipes, even rocks conduct these geomagnetically induced currents. And water. Just say. Together, Earth and power lines form an electrical circuit. If too much current flows into the power grid, it can cause a blackout. Space weather drives electric currents and magnetic fields in Earth's atmosphere that causes GIC. Geomagnetically induced current, GIC. GIC. Keep this picture in mind. I think I don't read further, I just show you some pictures. For example, this one. Scandinavia. Norway. Sweden. Finland. Russia. Estland. Denmark. So we just watched at this resistivity map. Now we are looking at the surface conductivity map. And obviously, if I understood it right, I may be wrong, but being in a spot like this where we have very much conductivity, or here, you are in a good place, it seems. Maybe I'm wrong. I tried to figure it out. We have a resistive map and a conductivity map. They are the opposite. So, if we go back to this other map, which was probably here, yes, New York, and these are here. They're blue and they're bad. But since we are talking about the opposite, we need a red to be good. Is it? Is it so? Which might be this red area here, which has a form of a C pinch. I don't know. Maybe. There's like craters here all over the place. Thousands. Finland, the land of the thousand lakes. Yeah, 1,000 craters. So now back to this article. That's not the paper. That's just an article written by a doctor. So here's this other picture down here. GIC, geomagnetically induced current. They have these here. Some of you might know about telluric currents and stuff, but I wanted to show you this. Introduction to Plasma Tectonics and Electric Geology. Solar wind coupling to planetary circuits. Lightning tells the stellar transformer story. Written by Bruce Leyburn and Giovanni Gregory. And in this paper, we have this one picture from Gregory with sea urchin spines. Joule antennas, hoop theory. So there is energy flowing through the mantle upwards in different circuits, in different categories of sizes and amplitudes, strength, and it fluctuates. It's alive. Some things move faster, some slower, some have slow rhythms, some have faster rhythms. They have different kinds of discharge amplitudes. And actually, I think I could end with my recent finding. If you keep this also in mind, this picture, and then you take a look at this. That's from the Italian Alps. I just found it while doing my last video. And these are the Alps. If I would show this picture to anyone, let's zoom out as far as we can go. This picture, and tell you that this is a volcano in Indonesia or something, China or South America. You would probably buy it. Yeah, okay. It's forest and stuff. But this is the Alps. And I have been talking about that glaciers are contemporary lava streams made out of water. Because the glacier bearing mountain is an actual volcano. And the glacier is the best evidence for that. And flash floods are really good evidences for that. Many volcanoes have water activity included. It is just seen as a side effect and nothing to do with the volcano itself. But we have this kind of basaltic lava, and we have rhyolithic lava. And somehow it seems that mineral water, geothermal activity, rhyolithic lava, they're on one side of the spectrum, and then we have basaltic lava and all these other things. What people know about the volcano. There's red stuff coming out there. And it can be really acidic. There's like acid lakes in volcanoes. They are really well known. But many forget the other side of the spectrum. The alkaline spectrum. Which brings us ultimately back to the white rivers. Why? Udine, Italy. This river. Yeah, I have no idea where I stopped before because I had to search for quite some time. But it was still the same paper. I just didn't find it. Anyway, I guess it was something about acidic lakes in volcanoes and stuff. Here is a paper. I won't scroll now anywhere because I finally found it. So here, chemical composition of surface water reflects the geological setting of the catchment. The Tagliamento is classified as an alkaline river with a pH up to 7.5, a specific conductance of 250 micro. Whatever this means, how you spell that. But anyway, there's obviously an alkaline river, more than one. I guess there are many of those. They just don't notice it. Which could indicate volcanic activity. Besides geothermal activity, sulfuric springs, and all these kinds of other things what I have been talking about. So I think this is really an interesting thing. But anyway, I leave it here. Thanks.